Welcome back to our next video. In this one, we will be continuing to work question 1 of the June 2021 paper. So continuing with part 4, it asks us to outline the mechanism for the reaction between compound Q and HBr. So depending on your structure, so compound Q is C4H8. So depending on how you want to draw C4H8, it'll either be but1ene or but2ene. So this is an alkene mechanism. If we're adding HBr, we know that the name of the mechanism is electrophilic addition. So first, we know that the HBr molecule, it is polarized, all right? So bromine being more electronegative than hydrogen, it will have a slightly negative charge, and the hydrogen will have a slightly positive charge. If you remember about a double bond, it consists of a sigma bond and a pi bond. And the pi bond as in a pair of pi electrons. Essentially, they are nucleophiles. So the electrons in the pi bond will attack the hydrogen of the HBr molecule. So that's the first thing that will occur. So a pair of electron is coming from the double bond. All right, so we use a curved arrow. Remember, fishhook is when we are transferring a single electron. So we are removing the H from the HBr. This bond, remember, every nucleophilic attack, the bond in the molecule that is being attacked, it is going to be broken heterolytically. And to show that when a bond breaks heterolytically, we know that one atom gets both of the electron, and it will be the more electronegative atom. In this case, it is bromine. So the pi electrons attack the hydrogen of the HBr. And the HBr bond, it is broken heterolytically. That is why you have two curved arrows. And remember, you draw the arrows from the source of the electrons to where it is going. So the electron is coming from the double bond and it is going to hydrogen. Here, they are coming from the bond and going to bromine. When you're doing this on the exam, put on the hydrogens, all right? Do not leave them off like I am doing here. Put them on. All right, so once that happens, we will know that we will no longer have a carbon to carbon double bond. Because this bond, it was broken and it will now be used to attach this hydrogen. Now, if you look over here, this carbon, it had 1, 2, 3, 4 bonds around it. But now this bond is gone to this carbon exclusively, right? To form the bond with hydrogen. So that means this carbon here, it is left with 3 bonds, all right? So that is essentially now what we have is a carbocation. All right, so we have a carbocation. All right, so in step 1, we have the formation of our carbocation. This was as a result of the nucleophilic attack by the pi electrons and the hydrogen of the HBr molecule. So when you're doing the mechanism, you can simply put for this step formation of a carbocation. All right, and you put in here curved arrows. On this side now, we're going to have an attack, a nucleophilic attack on the carbocation by the bromide ion. Again, you just draw your curved arrow. All right, so there you have it. Do the nucleophilic attack and we end up with our halo alkane. So whenever you reckon a hydrogen halide with an alkene, you will end up with your halo alkane. Now, bear in mind that if you had used 1-butene, your Markovnikov's rule would come into play. So remember, when you're adding a hydrogen halide, you put the hydrogen on the carbon of the double bond that already has more hydrogen. So if you use this structure, the bromine atom would be here and the hydrogen would be here. But if you notice, with butene, both carbons of the double bond have the same amount of hydrogen, 1 each. So it doesn't matter where you put it. But if it was this structure, hydrogen would go on this carbon of the double bond because it already has more hydrogen, and the bromine would go here. And so that is it for part C. Right, so for part D, it is asking about color changes when we use bromine, water, and potassium permanganate. So it says, describe the observation expected for each of the following reactions. Aqueous bromine is added to liquid pentane. Note, in sunlight. So pentane reacts with bromine, but only in the presence of UV light. So since as UV light is present, a reaction will occur. And so the bromine water will be decolorized. All right, if you want, let's say change from orange to colorless. So once UV light is present, if you remember, in free radical substitution, when you react alkane with a halogen, the condition is UV light. Sunlight is a source of UV light, hence they put sunlight. In part 2 now, it says aqueous bromine is added to liquid pentane without UV light. If UV light is not there, no reaction will take place. So you put no visible color changes will occur. All right, so no sunlight, no reaction. So you will not see any changes occurring. Cold potassium permanganate. Cold acidified is important. Cold acidified potassium permanganate solution is added to liquid. It should be pentene. And now, if potassium permanganate is acidified, it will change from purple to colorless with the alkene. You will not get a reaction with the alkane. All right, but with the alkene, it will change from purple to colorless if it is acidified. If it's alkaline conditions, it will be brown. So they put acidified for a specific purpose. It will change from purple to colorless. And that was it for question 1. If you have any question, leave it in the comment section.